Good afternoon and welcome to today's episode of the Dairy Signal. We're glad you could all join us today. Today's episode focuses on soil health and spring readiness, including what soil health looks like right now, how winter conditions may have impacted fields, and what growers can do to elevate soil health for spring planting. We are pleased to welcome Chris Bandura, Soils Program Manager with UW Extension. Chris works closely with farmers across Wisconsin, helping them understand soil function, evaluate soil health indicators, and apply practical management strategies that support productivity and long-term sustainability. Before we get started, I do have a couple reminders for you. This is a live program, so please utilize this time with Chris to ask live questions. To do so, there's three dots on the bottom right corner of your screen. If you go ahead and click those, you can submit or click ask a question, fill in your information, and then click submit. You're always welcome to answer anonymously. And for those participating for continuing education credits, a quiz will pop up automatically after today's episode, and be sure to click submit after completing the quiz. Before we get started, I do want to recognize one of our sponsors. DLF is committed to supporting dairy producers and dealers with genetics and varieties that they have come to know through Dairyland Seed and Pioneer Seed. They are the exclusive supplier of trusted genetics and varieties acquired through Corteva's Global Alfalfa program in 2023. They also provide continuity to the industry with larger companies exiting the alfalfa dealers and growers need a reliable, trusted partner such as DLF. We truly appreciate their sponsorship of this episode. With that, I'm going to turn it over to you, Chris.
All right. Thank you very much, Haley, and thank you for having me on the signal. This is my first time getting to speak with this audience, so very happy to be here. As Haley mentioned, I'm with UW Extension. I've been here for about 3 years in my current role, for about 3 months, working with other Extension colleagues around the state, working with farmers, consultants, and partners alike to tackle some of the harder challenges related to soil management, soil health, nutrient management, soil fertility. In my previous life, I spent about 7 years managing an agronomy testing lab in the Stratford, Wisconsin area for Dairyland Labs and Egg Source Labs before coming here. So coming to you from the Wausau, Wisconsin region today. So today, as Haley mentioned, we're going to talk a lot about soil health. And one of the things that's interesting about soil health is that although there are short-term things that can happen that impact things very quickly, soil health really is kind of a long-term game and a long-term approach to management. So we will address some of the shorter-term things. What might have been going on this spring or this last winter, and how does that affect soils here moving into the planting season. But a lot of what we talk about today will be a little bit more holistic and bigger picture thinking. So to kind of summarize where we're going to go today, we've kind of bring you the buffet style of soil health today to give a good overview on a couple different things. So we'll talk a little bit about why do we care about soil health? What really is it? What do we mean when we talk about that? High level discussions on the principles of soil health management. What can you do on the dairy and other cropping systems to advance soil health on your acres? Touch really quickly on a couple of soil health wins in the state. We'll look at some trends in adoption of different practices. And then we're going to wrap up today looking at some soil health testing research, really trying to come up with some ways that you can use soil health testing on your acres, have a better understanding of what some of those soil health tests mean, and kind of some things to watch out for when you're soil health testing on your farm. So with that, let's go ahead and dive in. So we're going to start off with some rhetorical questions, given that we're separated by what is the ether here today. We can't interact, but just get the thought process rolling here. So if you lost 30% of your purchased fertilizer or manure nutrients due to a hole in the storage tank, I'd be willing to bet that'd be fixed by tomorrow. I know we would do what we could on our farm, get that thing patched up ASAP. Now, fast forward, think about the field, right? If you lost that same 30% of a purchased nutrient due to denitrification because of poor soil structure and soil moisture management, what are we doing to address that? Are we taking time to think about, what can we do out in that field to help alleviate some of those soil moisture dynamics that are resulting in excessive nitrogen loss is there anything we can do, and are we thinking about that and trying to figure that out? So just kind of a different way of thinking about nutrients and how soils and soil health and function can mitigate that. Another interesting case to bring up when we're talking about why we care about soil health is thinking about weather. So if you think back 2023, we had a rather dry year throughout most of the growing season in most parts of the state. So the question here is, was your cornfield one of the first or one of the last to curl up and really be starving for a drink of water? Conversely, in 2024, we had some really, really wet conditions, in many cases, excessively wet and prolonged periods of wet conditions. How did your fields hold up to that? And then what about those weather whiplash scenarios that are seemingly becoming more and more frequent, where we go from excessively dry to excessively wet in a very short period of time, and sometimes several times back and forth? Soil health can really help us deal with some of these environmental stresses that our crops undergo. And we'll talk more about why that is later. And then lastly, this is an obvious answer to this question, but really, would anyone be upset if our soils allowed for more days in the field, especially in spring and fall? And here we're talking about workability. Can we get out there a week earlier, 3 days earlier to start spring activities without causing rutting or resulting in excessive compaction due to those wet conditions? Can our soils hold up some of that force and pressure of our implements and operations a little bit better? And so my whole point here in some of these what might seem like obvious questions um, is really to get us to understand that when we talk about soil health and when we promote managing our systems to promote and enhance soil health, there are a lot of very practical outcomes and applications when we think about this. We're thinking about nutrient cycling, soil moisture dynamics, and how that results in stress or stress alleviation to our crops. We're talking about compaction and the amount of yield that farmers in the Corn Belt alone lose every year due to compaction. There's a lot of very significant practical agronomic, economic, and environmental outcomes when we think about soil function. And so this is likely something that's very familiar to most people. We talk about soil health. We bring up the three different aspects of soil. We have the physical aspects, the chemical, and the biological. Just to call out a couple of specific things, what are we specifically focusing on here in that physical aspect of soils? We're honing in on soil texture, the effect that soil texture has on things like infiltration, or that surface soil property where water is entering the soil surface, infiltrating down into that soil profile to be accessed by crops or stored for a later date. We're looking at water holding capacity, soil structure, and how does that tie into the overall function of our soil. So those are the big physical components that we talk a lot about. On the chemical side of things, this is probably most familiar to folks aside from texture and things like that. Generally, it's quite common that folks will do routine soil fertility testing on their ground every 2 to 4 years, looking at things like pH and plant available nutrient levels and maybe cation exchange capacity. So here we're bringing that into the discussion of soil health as well, because we know that for example, if pH is way out of line, maybe we're in a really acidic environment, we know that that's going to have some biological effects on biological communities that can't thrive and proliferate under those extreme acidic conditions. In that biological space, right, we're zooming in on that living aspect of our soils, the stuff that's harder to see, bacteria, fungi, nematodes, protozoa, earthworms, all of these things that are actually living and breathing and doing work underneath the ground surface for us. And really, a lot of what they're contributing to, amongst other things, is nutrient cycling. Again, another big function of our soils that we care about a lot. And so the main point here, and the reason why we bring this up at the start, is that all of these things, all of these different attributes or characteristics of soils work together to result in some function, right? So when we're talking about management, how do we change management to enhance a soil physical property or a biological property, chances are if we move one lever over here to enhance, say, bacterial communities in our soils, we're inherently going to be moving levers over here on the side, on the physical and chemical side of things. Everything is connected and works together to function. And so if you haven't picked up on it yet, my brain always goes to soil health is all about function. And the NRCS definition really encompasses this concept as well. It's the continued capacity of a soil to function as a vital living ecosystem that supports plants, animals, and humans. In other words, for folks that might think more like I do, what's a simpler way to talk about this, right? Can a soil do the things that soils do to the best of their ability? And that's what we're really all about. And so we're just going to highlight for today's discussion, as I think it's relevant coming out of winter, coming into the planting season and the fieldwork season here. We're going to highlight two functions of soils out of the many that soils do for us and drill in a little bit more. So first things first, we've hit on it a little bit already, but we're talking about regulating water. And so here's a picture. This is a pretty classical example of a rainfall simulation demo that you might see at a field day. What you have up on the top of this picture is four different soil profiles being represented or cropping systems being represented. So from right to left, you'll notice that we have increasing ground cover, increasing living plants, decreased disturbance. As a result, after running this rainfall simulation, 1-2 inches of rainfall, what you'll notice is that the amount of runoff and sediment loss and infiltration changes as you move from right to left. So those systems with bare soil, very little cover, lots of disturbance, little structure, all of these things kind of compounding, you'll notice a lot of chocolate milk looking water out in front of that pan on the right. And very little of that water infiltrated through, hence the empty glass jar on the backside on the right. Conversely, way over on the left, you'll notice that there's very little water, and what water did run off of that system on the far left of that picture is very clear. And we have a lot more water that infiltrated into that system that will then be accessible to plants at a later date, increasing overall water storage. And so the concept here again is tying in these management topics to help enhance the function of our soils, to increase infiltration, to decrease soil loss. And when we can do both of those things, right there is a great start at building soil health. The other function that I think a lot of us are quite interested in, especially in times of rather high nutrient input prices and not necessarily fantastic commodity prices, is this concept of nutrient cycling. All right. So if we zoom way out, what are we really talking about here in the context of soil health? And really what we're after is thinking about our microbial communities, our bacterial communities, fungal communities. How abundant are they in our soil environments and how active are they? And so the concept here is that the more microbial communities we have, the more diverse they are, the more active they are, the more work, the more nutrient cycling they are going to be able to do from things like soil organic matter, so nutrients that are bound up in inherent soil organic matter. Many of us on the call here today are in these dairy cropping systems where we have previous forage legume crops that eventually have to be broken down and transformed by biological communities to release that nitrogen in the case of alfalfa or clover to next year's corn crop. We need bugs to do that. Also manure. The stronger that microbial community is, the more we're going to get out of that manure as a nutrient source and a carbon source in our environments. And so the concept here, again, more microbial abundance and diversity and activity. Perhaps we can be a bit more efficient with those inherent and organic sources of nutrient and become less reliant on synthetically applied inputs. So, okay, we've talked a little bit about why do we care about soil health, What do we really mean by that, right? It's all about function. Talked a little bit about water management, nutrient cycling. We're going to shift gears a little bit now and talk about some of those soil health management principles. There's typically five that we're gonna kind of blow through relatively quickly for sake of time today. Bring some specific things for dairies to focus on before we wrap each one of those up. So the first one that we're going to hit on, spend a little time on, is minimizing disturbance. And so typically, what we're talking about here is minimizing the frequency and intensity of tillage. We know that there are other forms of disturbance that our soils will experience in our agricultural systems. Thinking about manure management, maybe we're not technically doing tillage, but we're injecting manure. That's still a disturbance. We're still, even if we're using no-till planters, that's a disturbance. If we are driving over the top of that field with heavy equipment, that's a disturbance, right? So there's lots of different things we're talking about, but predominantly what we're focusing on here is tillage. And so the image on the right, you've got kind of two different examples being illustrated to you. You've got on the left, panel A, a nice aggregated soil. What does that mean? Those soil, sand, silt, and clay particles have come together over time to form aggregates, and then contributing to overall structure of that soil. And what that does is it creates natural, what we call natural plumbing, or natural flow channels for water to easily infiltrate from the soil surface down into that profile, right? So enhancing infiltration, therefore reducing runoff. Conversely, typically soils that are disturbed more frequently, more intensively, in combination with very little cover at the soil surface, they're more susceptible to crusting, generally no or weaker aggregates, more prone to runoff and erosion. And so when we run those tillage implements through our soils, we are disrupting that aggregation process. We're breaking aggregates apart. We're disrupting structure, and ultimately we're cutting off those natural plumbing or those natural flow channels, pore spaces, macro pores for water to flow down into that profile. Another thing that we're concerned about, again, in this context of soil health when it comes to tillage in our systems is disruption of fungal hyphae networks. So these are fungal communities, microbial communities that form associations with plant roots. And they're actually really great resources for plants. This is a relationship that we want to encourage in our soils is plants associating with fungal hyphae, and so these fungal networks can, once associated with plants, can go and explore greater volumes of soil further in proximity from that plant than what their roots alone can access. And so, going to find nutrients and water and other resources beyond what that plant root itself can do. And again, when we run those tillage implements through the field, we destroy those fungal networks quite readily. Last point we want to bring up, why do we care about reducing disturbance? And really this is thinking about just overall organic matter and carbon management. And so it's been estimated that since the onset of conventional tillage in our agricultural systems in the upper Midwest, we've lost about 50% of our native organic matter. Organic matter, as most of us are very aware, is so critical to almost every function that soils do. Thinking about water storage, aggregation, infiltration, nutrient cycling, all the things. Organic matter really contributes to everything. And so being able to reduce disturbance, reduce the frequency that which we're exposing that soil organic matter to big flushes of oxygen and burning off that oxygen from enhanced flushes of microbial activity, the more of that organic matter we can retain. And so what do we want to do here? What are we really talking about trying to encourage folks to work on or think about? That's my job today, is to just get people thinking about these concepts, thinking about some practices, take them back to the kitchen table and figure out what works. Unique challenges in these dairy systems, these heavy dairy systems. We have a lot of manure to deal with, and in a lot of cases, that manure's got to go on a field and get incorporated. And typically, traditionally, that's done via tillage. So again, acknowledging that that is a challenge right off the top. The other thing that you could argue is uniquely a challenge, or that's maybe a bit more of an amplified challenge in our dairy systems is traffic. With all the different field operations, forage harvest, all the things that are happening, manure management. Um, we have a lot of traffic disturbance happening on our fields. And so opportunities for us here, I think, leaving today, try your best to stay off of wet soils, number one. Most of our compaction happens on that first pass across the field that was too wet to withstand that force of that implement or that equipment. And so, if our friend Jamie Patton from NRCS was with us today, she'd probably give you some advice that sounds a little bit like go have a drink and play cards, right? Have some patience, find something else to spend our extra day or two on, and then go out there when that field is a bit more able to handle that stress. Okay. Also, just be thinking about ways to transition into reduced tillage. And what do we mean by that? If we're still using moldboard, can we use something that's a bit less intense to do our tillage operations? Can we think about doing no-till corn after hay and cover crops instead of working that whole field up prior to planting corn? Again, that comes with some other trade-offs we've got to think about on terms of how we set that corn planter up to deal with that. But again, can we be thinking about that? On the manure side, low disturbance manure injection, not a new concept. There are challenges with that, of course, right? We have typically application rates. Maximum application rates are typically lower with LDMI. So I understand that incorporates or adds some added logistics and labor concerns. But again, it is a lower disturbance way of managing manure. And then again, thinking about strategic traffic patterns during harvest. All right. So moving on to our next soil health principle, we're going to talk a little bit more about maximizing biodiversity. Here, we're going to move a little bit quicker through the rest of these, but we're talking about number one, our main crop rotation. So are we corn silage on corn silage? Are we corn and alfalfa? Are we also adding a small grain like wheat or oats into that rotation? Do we have any pasture systems being incorporated across that landscape? So really just trying to figure out how do we diversify, maximize the amount of different types of plants and root structures and so on and so forth into our systems. Within that main crop rotation, let's say we are corn on corn. Can we consider using cover crops to help diversify the roots that are being exposed in those different systems? Within cover cropping, we can talk about, are we using monoculture cover crops or are we using multi-species cover crops? Again, anything we can do to enhance the diversity of that system. Again, we can think about things like alternative forages to help, again, different roots, different plants, doing different things for us. Also can help us with things beyond the soil health and soil function itself. So incorporating alternative forages can help break up pest cycles and all sorts of other on-farm benefits from diversifying. And then, of course, just throwing grazing out there again. What I've done here, typically we have 5 principles we talk about. I've boiled them down into 4 slides. I'm including use organic amendments as part of maximizing biodiversity. So using things like manure, which I think most folks on the call today, great job. You have one of the best resources we can have for building soil health at your disposal. But adding those organic amendments is great for promoting biological abundance and activity and soil health in general. The next thing we will cover here is maximizing soil cover. So what are we talking about here? We're looking at residue management. So any grain acres, specifically corn grain acres we have out there, we leave a lot of residue behind. A lot of times that residue is taken off the field for one reason or another, or it's incorporated right away for one reason or another. Leaving that corn residue on the surface actually does a remarkable job of intercepting raindrop impact, protecting that soil surface, slowing down moving water across that field. Again, promoting infiltration reducing runoff, that residue management can go a long way. So be thinking about that on your operations as well. In the middle, you've got two images. On the top, you've got a young Berseem clover that was planted into wheat, volunteer wheat regrowth ahead of a corn grain system. So, talking about fall cover crops, the picture on the bottom in the middle is actually what a 2 ton of dry matter Berseem clover cover crop after wheat looks like in the spring. It winter killed, and so even though that is a dead cover crop, that's dead residue out in that field, we still had 50 to 80% soil cover from that winter killed clover cover crop. And again, that is going to slow down moving water, intercept raindrops, and really take the blow out of that rainfall in protecting that soil. Top right, you've got your classical cereal rye biomass mat in between your corn rows. What is that doing? Same things. Raindrop impact, slowing down water. It's also going to keep that soil a little bit cooler. We'll lose less moisture from evapotranspiration off that soil surface. It's going to help reduce weed seed germination. So there's all sorts of things beyond just soil health building in and of itself that these practices can help us with. And the last one, lower right-hand corner, introducing or bringing up this concept of alfalfa grass mixes to enhance overall soil coverage. I'm going to just throw this up there so you don't roast me in the chat. I am not a dairy nutritionist. I don't know what it takes to successfully feed a herd of dairy cows, heifers, dry cows, all the things. So I recognize that we are constrained by what our animals need to be eating. My job again is to bring in concepts. So alfalfa, pure alfalfa stands, there's relatively a lot of space, a lot of bare soil between crowns out there. Can we add some other species in there? Again, while meeting our forage quality goals and tonnage goals to help cover that soil a little bit more than just alfalfa on its own. All right. And so then the last principle we're going to talk about today as you head into kind of the 2026 season here is maximizing living roots. And what's so special about living roots, right? I thought we just talked about living or soil cover. Well, how is this different? So what's really different about living roots is that as plants grow, and we're talking every plant, as plants grow and they do photosynthesis, they're bringing carbon dioxide, carbon in from the atmosphere, assimilating that into and through their plant biomass. But plants are also leaking carbon out of their root systems. And so as those plants grow, they secrete what we call root exudates out of their roots into that soil environment. And those root exudates are actually great carbon or food energy sources for microbial communities, to enhance and bolster what those microbes can do for us. Those root exudates are also rather sticky, and they help with the soil aggregation processes that we talked about at the beginning of our time together today. And so they do a lot of things below ground for us. The other thing that living roots are great for, thinking about water management functions again, is creating direct conduits and pathways for water to enter that soil surface much, much easier. So what are some opportunities there? Again, think about our rotation. Can we restructure our crop rotation such that we're maximizing the number of days a year where we have a living crop in that field? We can frost seed. If anyone on the call is using winter wheat in their rotation, you can get some clover established a little bit earlier, frost seeding that early in the springtime here to get that clover going. We can also do interseeding, which is early season planting cover crops in between corn rows to get those established and growing earlier. We can also do overseeding. So when corn leaves are drying down, soybean leaves are drying down, can we broadcast some cover crops over the top of those main crops? All right, so transitioning into some information, some data here. Looking at some soil health wins in Wisconsin. We're looking here at some conservation practice adoption in the state. So on that figure on the left, you're looking at Wisconsin estimated cover crop acres in the state from 2012 through 2022. Nice to see a general upward trend in the number of acres under cover crop. Again, these are estimates. These are not actual hard truth numbers. So great to see the increase in trend, but do recognize that that is still representing less than 10% of cropland acres in the state. So we have a lot of work we can continue to do, which also means there's a reason, right? There's got to be a reason why we're only at 8 to 10% coverage, and so it's our job collectively in this industry to work together to address the barriers, the challenges that folks have in front of them to get more covered ground. Similarly, with no-till and reduced-till, which we can define probably a million ways what reduced till actually means from this survey. But again, we see kind of an upward trend, a little bit of a slowdown between 2017 and 22 in terms of the number of acres. But good news here is that over 50% of the cropland acres in the state are under no till or reduced till. So good to see that on the landscape. And so then kind of like, those two things help contribute to this. So what we're seeing here now from a different source of information from USDA, looking at estimated annual soil loss. So this is tons of soil per acre per year on the average across the state of Wisconsin. So what we'll notice right away is that unfortunately, right, that's an upward trend. That what this means is that over time, we're still seeing annual estimates of soil loss increasing year over year. The good news is that from 1997 to '07, where we saw about a 0.05 ton per acre per year increase in soil loss, from '07 to 2017, that was a 0.03 ton per acre per year increase. So we're slowing the rate at which we're increasing soil loss. So ideally, when the 2027 data comes out, hopefully what we see is a full leveling off or kind of a change in direction here where soil loss estimates are actually going down given the enhanced adoption of no-till, reduced-till, cover crops, all sorts of other practices that we haven't dove super deep into today as well. Lastly, I also want to just give a shout out to a program that I think has really done a lot for the state. The DATCAT producer-led watershed groups talk about getting a lot of really, really cool things done when you throw farmers in a room to solve a problem. I think this has just been a really great and intentional way for farms to come together with a little bit of resources kind of behind the initiative, but coming together in those local watersheds, getting all the folks talking to each other, talking about the problems and solutions. And really what we've seen is in the watersheds where those groups exist over time, we're seeing, again, enhanced adoption of not just soil health or soil conservation management practice, but other best management practices too, primarily thinking about nutrient management as a whole. Seeing a lot of great impacts coming from there. So just wanted to kind of shout out some of those cool things that are happening in the state and the awareness that's being built around the state on the soil health topic. All right, so this is your last transition on the buffet line today. Again, I mentioned at the beginning we've got several different topics, but just trying to get different thoughts provoked here today. What we're going to do at the end here is bring up soil health testing and just give you an overview of some research that we've been working on at UW. This kind of does get at what is the current state of soil health in the state, kind of like our own little State of the Union address, if you will. So kind of neat here. So a lot of the questions that we get when we're talking about soil health are listed on screen here, right? Why test it? Why do we even want to talk about testing soil health? What we want to learn? What test should we use? What do the results mean? What do we do with the results? What's a normal or a good value? These are all things that we've been hearing for a long time. And so we're excited that we've got some information that we can share with folks. The first thing we want to acknowledge this before we dive into some data is this one slide talking about the value added use cases for soil health testing. Again, why do it? And again, aside from soil health testing, I want to call out the fact that there's a number of ways to evaluate soil health on your farm. It does not have to be by use of a laboratory test by any means. There's a lot of in-field visual assessments, hands-on assessments, things that you're just going to notice when you drive by in terms of, oh, hey, that field isn't ponded or it wasn't ponded for as long as it usually is, or wow, it was a really dry year, but my soil moisture seemed to just be a little bit better. And hey, guess what? That showed up in tonnage or in grain yield. So there's all sorts of ways to evaluate how our soils are functioning. But with soil health testing, one of the most common use cases that we end up talking about with folks is this concept of just establishing a baseline understanding and monitoring things over time. And that concept applies whether you're a farmer, a producer that does not intend to make any management changes, or if you are a farmer that wants to make all the changes in the world to try and move that soil health needle on your farm. It's really critical to establish a baseline, quantify soil health in some way, in this case using testing, laboratory testing, do your changes or maintain status quo, come back every 3 to 5 years, reevaluate things and see if soil function is moving in the right direction. Another common thing or reason to use it, right? How can I use soil health testing to inform nutrient input decision making? This has been a hot topic in the past couple of years, specifically thinking about the Haney Soil Health Test Assessment or the Haney Soil Health Assessment. Stay tuned on that. So, admittedly, UW is a bit behind the eight ball on evaluation of utility of the Haney test in the state. Really excited to share that by the end of this growing season, we'll have about 80 site years of information where we've collected Haney soil health tests, some other soil health tests as well, and we're going to be able to directly correlate and evaluate are these indicators or these pieces of these soil health assessments related to things like optimum nitrogen fertilizer rates, yield levels, the amount of yield that we get from applying nitrogen, all sorts of really interesting and applied questions like that. So stay tuned on that. We've got some exciting stuff coming down the pipeline from that. Lastly, and what we're going to just stick with for the remaining few minutes today is this concept of how does the soil health on my farm compare to that to my neighbors or to others around the state that are doing similar things. And so this is where we're talking about soil health benchmarks and normal values. So we're gonna dive right into that here now. So the goal with this benchmarking project was to provide you all with research-based, contextualized interpretation of soil health in Wisconsin. What these benchmarks are is they are simply normal values. This is what we typically see across the state on specific kinds of soil under specific management regime. What they are not, what these benchmarks are not, are target values that you must hit in order to achieve some desired outcome. That is not what we're trying to infer in this work here today. But just a quick overview, there's about 850 samples collected from across the state. You can see that inset map there of all the sampling locations across the state of Wisconsin. We have 7 different soil health tests that have been analyzed on these samples. And in addition to that lab data, we also have a lot of other information, what we call metadata. It's kind of data about the data. And so what we mean here is we're looking at things like what was the soil texture, what was the soil drainage class, what was the management history on that field over the past 5, 10 plus years. And so we were able to merge all of this information together to try to develop this interpretive tool for folks to use on their own farms. And so like I mentioned, on the top here, this is kind of the process that we took to develop things. We looked at texture and soil drainage class. Those are our inherent properties. So whether we like it or not, Mother Nature dealt us a hand. We're stuck with the inherent soil properties that we have. We're not changing those. But what we do recognize is that they are super, super important, and they really do control kind of the what's possible in terms of overall soil health levels, what's possible in terms of change. So anyways, we have that data. We use that in our process. We also looked specifically at some of these other factors, including cropping system. So are they annual systems or perennial systems, pasture systems, manure history, right? Did that field have a manure history? If yes, for how long and what kind of manure? And what were the historical rates, all that nitty gritty stuff, cover crop history, tillage, residue management, all the things. So what we did with all this information is we jammed it into our statistical magic 8 ball and said, hey, we really need to find a very simplified but valuable place for people to start on this interpretation and contextualization process. And kind of the first result of that landed us here with 3 different benchmark groups. And so I'll kind of just walk us through the order of how this kind of all parsed out. So the first group of data that was separated out of this data set was anything that came from a pasture system. So regardless of soil type or anything else, if the cropping system was a pasture, that data got put into a separate bucket kind of over on its own. Then, once those pasture systems were removed, it said, okay, across all of the non-pastured cropping systems and all of that other management, what's the next most important thing we need to account for right off the top? And it came out to be soil texture. So sandy soils got lumped into a bucket. And then, of course, medium fine textured was everything else. So here, what we're seeing show up in this data-driven approach is that both management and inherent soil properties are really important to consider when we're interpreting soil health test results. So just an example, we're not going to go through 7 soil health tests today. I'm just going to show you 2 examples so you can just get a good visual. This is soil organic matter. So this kind of old tried and true Grandpa's 30-30 for the deer hunters on the call today. Organic matter has been around a long time. We've been talking about it for a long time. It's very routine and accessible. So we wanted to make sure we talk about it today. But what you'll see here is you have sand on the left in that black color, medium fine textured soils in that red color, and then pasture systems in that gray color. And so you'll see very clearly that the benchmark values of organic matter increase as you move from left to right. Again, highlighting that the effect of soil texture and of cropping system. The benchmarks, what are those? So let's pick on pastures since they did tend to be the highest kind of across the board. So you'll see underneath the box, you'll see a 4.0%. That's the average organic matter of all the samples in that pasture bucket from this data set across the state. That range, 3.3 to 4.5%, what we're calling the normal range. What that is a really fancy way, it's called the interquartile range, fancy way of saying it's the middle 50% of the data. And so if you ever see these box and whisker plots at various talks, the inside of that box is the middle 50% of data. And so again, this data-driven approach to delineate these categories, sand, medium, fine texture, pasture, also within each of these categories, it's a data-driven approach to decide what is that normal value in range. So just give you a peek behind the curtain where this comes from. Last example I'll show you today is mineralizable carbon, also known as soil respiration, also known as biological activity. This is our soil health test that is an indicator of biological abundance and activity. Same trend can be observed here, where sandy soils have less microbial activity generally than medium fine textured soils, and then pasture systems, regardless of texture, greater than non-pasture systems. So, like I mentioned, we've got 7 tests in total. The other thing that we're not going to go through today, but I want you to know that we've got it available within each of these 3 buckets: sand, medium, fine, and pasture. We also drilled down even deeper. So, for example, we said within the pasture group, what else was important? What else do we need to keep in mind when we're trying to interpret and understand soil health tests on our farm? And so, just for example, within those pasture systems, soil type still mattered. So, again, within pastures, there was a separation in organic matter and mineralizable carbon here between coarse and medium fine textured soils. So that is still, if you were a pasture, you have pasture on your farm, you want to pull organic matter results, or tests rather, you would have the ability in this resource we're working on getting out there to look at a row that is sandy pastures or medium fine textured pastures. Again, refining and further enhancing the context that's being provided to you. The other thing about pastures, this is no surprise, but it's really cool to see, is that the duration of time that a field has been under pasture management also matters. So very young pastures exhibited overall lower soil health than 20 plus year old pastures, for example. Not surprising, as pastures really are pulling together all of those soil health principles in one setting at the same time. And so the longer you do that, the greater these soil health test numbers that we get. Okay, so all this will be available in the near future. At the very end today, there'll be a QR where you can actually go to a web tool and explore all this stuff on your own and go down all sorts of fun rabbit holes. But just to kind of wrap this up for today, take home points, right? Soil health is all about managing for soil function. The big ones that we all care about, I think, going into the growing season here, infiltration is a big deal. Water storage capacity is a big deal, as is nutrient cycling. Again, there's those five principles that we talked through regarding soil health or soil conservation management, really. Again, on soil health tests, they are supposed to be indicators of soil function. And so keep that in mind when you're thinking about soil health tests or evaluations. They're really like a proxy, an indicator of what's happening in and through that soil environment. Again, I'll stress that interpretation of these tests must include some context about the soil type at a bare minimum, sandy versus clay loam versus silt loam. That matters a lot. And then if you can include some understanding of historical background management there, that's even better. And then what I'll leave you with today is that research shows that persistence and patience following implementing as many of these practices that we've talked about. The longer we can do that, the more of those practices we can implement, it will have a positive effect and impact on soil function. So again, where we started, this isn't a short-term game. This is a long-term way of thinking and managing our farms. Same with a tree. The best time to plant the tree was yesterday. Second best time is today. Same concept applies for initiating soil health on your farm. So that's where I'll end. The QR code on the left will take you to a web page with 4 different articles that are very relevant to today's talk, breaking down soil characteristics, soil health in general, a little bit more on soil health testing. That QR code on the right is that data explorer that I mentioned a few minutes ago. You can actually go in there and can kind of control how you want to look at combinations of soil type and management practices and observe what's happening to soil health test results as a result of changing those things around. So have any questions after today on anything, or you just want to talk about the Packers or deer hunting or whatever, I'm always happy to chat. My info is there. You can call or text anytime. So thank you.
Awesome. Thank you so much, Chris, for all of the great information that you shared with us today. I did have a question, going back to when we were talking about the principles, and you mentioned organic amendments, and you had mentioned that manure was one of them. Are there others, or is manure the primary one?
Yeah, good question. So manure is certainly the most common one that we think of, and that frankly, I know manure can be a challenge for producers in the state to manage all at once in the fall or spring, but it really is a great thing for adding carbon and nutrients and stimulating biological activity. A lot of the other types of organic amendments we're thinking are other composted materials that can be land applied. There are some other, like municipal or other just biosolids in general that are high in carbon, high organic content that we can safely apply to the landscape as well. But manure is certainly our most common.
Awesome. And then the second question I had, we obviously talked a lot today about soil function, but is improving soil health only important for improving soil function, or does it benefit other things beyond the soil itself?
Yeah. That's a really good question. Of course, in the scope of today's talk, it's what can we do above ground to enhance what's happening below ground and to keep soil in the field. But when we talk about soil health, and particularly holistically thinking about soil health management or soil conservation management, um, thinking about things like cover cropping, for example. We know that yes, doing cover crops is great and has benefits for soils and soil function. But something I mentioned, I think on one of the slides is that if we can manage that cover crop in such a way where that cover crop residue remains on top of that soil surface and is dead throughout the first several weeks of the corn growing season until that corn can canopy, um, or closed canopy rather, that cover crop is not only doing great things for soil, but it's also going to help suppress potentially pesky weed seeds from germinating and emerging and getting away from us, putting a tax on our herbicide chemistry program in that field. Um, Overall, when we think about what happens when our soils do function at higher levels, one of the more interesting discussions that we're having a lot more lately is thinking about that weather whiplash thing we talked about at the beginning. So what we're talking about here a little bit more is resilience. And so if we've got a soil system that can infiltrate more water and store and hold on to more water for longer periods of time, whether we're in an excessively wet year or an excessively dry year or both in the same year, what we're seeing over the long term is systems that have the ability to do both of those things, infiltrate and store. What, Typically, what you'll see in those systems is the gap or the difference in yield level from a really bad year to a really good year starts to shrink. And so it's not necessarily that the expectation is that greater soil health will result in greater yield, higher tonnage, better grain yields, better quality. In some cases, that's true. But the idea behind this building resilience aspect is that even in a bad year, right, our yields will be less bad, right? Instead of dropping 20%, they only drop 10%. And then the ceiling for maximum yields in a really good year maybe goes up a couple percent as well. So shrinking the good from the bad and having a more consistent and steady expectation of what's coming off of our fields.
Awesome. Thank you again, Chris, for joining us today. We truly appreciate your time and sharing with us all of your tips for soil health and soil function. With that, I would also like to say thank you again to DLF for sponsoring today's episode of the Dairy Signal. DLF is a farmer-owned seed company and the world's largest forage and turf seed leader with 2,200 employees in 22 countries. 11% of DLF employees worldwide perform research, running plant breeding programs globally to produce varieties that flourish in harsh climates, challenging soils, and for the most demanding audiences on the planet. And thank you again to everyone for tuning in today. We look forward to seeing you on the next episode of the Dairy Signal.